Hello! Welcome to physics lesson 11.5, electromagnetic fields. Alright, so let's start off with an electromagnetic wave. An electromagnetic wave is a wave that has both an electric field and a magnetic field. So this electromagnetic wave is giving off radiation in the form of a transverse wave, and what that means is the oscillation, so the crest and the trough, are going perpendicular to the direction of motion. So the energy is going this way, or the direction is going this way, and the energy is going up, or it could also be going out the other way. It has to be perpendicular, which means it's making right angles. And these two show the direction going out and up. Also, it's important to note that just because they are perpendicular to each other does not mean that they're out of phase. They're actually in the same phase, so both the electric field and the magnetic field reach the maximum and minimum at the same points in the same space. And that's what these diagrams here, which I borrowed from Wikipedia, show. Hey, interesting fact. Teachers use Wikipedia too. Oh my goodness. Excuse me. Alright, so magnetic field is a vector field. That describes the magnetic influence and currents of magnetized materials. Its symbol is B, because it is. The unit is a Tesla, capital T. So magnetic fields are similar to electric fields, so they still go from positive to negative, but we're looking at north to south. So north is positive, south is negative. But in reference to your paper, it can go up on your paper, it can go down on your paper, it can go left on your paper, it can go right on your paper, and it can go into your paper and out of your paper. So I suggest pausing this video and taking your pointer finger and practicing the directions that they're going. So your pointer finger is going to represent your magnetic field. Practice it going into your paper. Practice it going to the left, practice it going down, practice it going up, right, and out. This one can be a little bit tricky to get your hand going out of the paper, but remember, your pointer finger is showing the direction of your magnetic field. Alright, I'm going to assume that you paused it and you were messing around with your pointer finger, and now you're going to come back and we're going to look at the other components. So this is known as your right hand rule, and your thumb is your velocity or current. Your magnetic field that we already talked about was your pointer finger, and your middle finger is F. And you essentially want to hold your hand like you're pointing, then put your thumb straight up. Your middle finger is going to go out perpendicular, so all three of them are perpendicular to one another. And it might be a little bit difficult to keep your middle finger out depending on your dexterity, so feel free to have your other two fingers with it, so three fingers are going to the left. But you should have your right hand, and it has to be your right hand, that's why it's called the right hand rule. Your middle finger should be pointing to the left, your pointer finger should be pointing away from you, and your thumb should be pointing up. And this works for positive charges. Alright, so let's go back to this page right here. Let's say that our magnetic field is still going in. Let's say that our force is going to the left. Right there. What direction would the current be going? So take your pointer finger, point it directly at the computer screen, or if you have your notes, point it directly into your notes. Then take your middle finger, point it in the direction that's on the slide, and then make sure that your thumb is also pointing up. What direction is the current going? The current should hopefully be going up. So I'll take this, so current is going this way. Now let's take a look at number 6. Let's say the force is still going to the left. Now the magnetic field is coming out of your paper. The force is going to the left. So your thumb should be pointing towards you now, and that's the direction of your current. I know it's a little bit hard to go back and forth. A little bit of practice will do you a world of good. Now, when we look at negative charges, we use the left-hand rule. And the left-hand rule is the exact same as the right-hand rule, only now you use your left hand. Same idea. There's also right-hand rule number 2, which shows that the magnetic field wraps around a wire and the current is carried through the wire. Still take your right hand, your fingers represent your magnetic field that wraps around, and the thumb represents your current. It works with a hoop as well, only with a hoop, the magnetic field is your thumb and your fingers are your current.
Good afternoon.
All right.
Staff and
Have a good day.
students.
I'll talk to you later.
Students.